Hello and welcome to. I haven't decided the name yet, but yeah, I was searching through internet for this distributed k-means clustering, and I couldn't figure out where it is, and not even any website or articles have covering this distributed k-means clustering. So I thought I'll make a video. So let's get into it. So first, you will find plenty of videos explaining beautifully what the k-means clustering is. So please do watch that. But still, let's dive into it. So k-means clustering is unsupervised learning. So like we are using this. Cluster data, and we have unsupervised data, so there is no label, right? And then how it works is like k means partitions the data into k clusters. So like how we will find this k is we will use this elbow method that you will find it in any YouTube video that after that particular point of time k like basically goes that in plateau state, I guess, and then there is SSE here, and then here is the K. So number of K is like it is not that high and that low. That so that is a perfect way to find out the K centroid or K clusters. And how it works is like choose the number of cluster K and randomly assign the center K centroids. Mm, it can be anywhere, and assign each data point to k nearest centroid. Okay, and yeah, we will do that and update the centroid as the mean of assigned points. So like we will now update this centroid whatever the mean is, this centroid and this centroid as well, and then it will repeat until centroids are not moved. So yeah, that is all about k-means clustering. Now, what is this distributed k-means clustering? So finding this distance via Euclidean or Manhattan distance takes time, right? So we are like first doing the elbow method and finding the k, right k is measured, and then we are doing this clustering and updating the centroids, like doing mean, finding distance. Everything takes time. So we can do this via distributed k-means clustering. That means that we are assigning a work into different rank. We call it thread or different processes. Actually, Python doesn't support thread, so that is why we are using the term called rank. Uh, because there is a whole GIL thing, so you'll read it somewhere. So yeah, now step by step breakdown of this distributed k means. First of all, we will have the master node, master rank 0 usually is the master rank. What it will do is choose k random points, initialize the centroid as we do in k means. It is the same version, right? It is all like k means only, but the thing is like we are distributing the work among many different ranks, or here it is defined as node. So broadcast this centroid to all the workers. So like all the worker will know that where is my centroid. And like here we are picking three centroid, like k equal to 3, and this is the their x and y axis, and then assignment phase. So like now what we'll do is like um each worker node independently for each local data point, it will compute the distance from the current cluster centroids, and it will compute the distance. So let's say we have 5 ranks. So the data local data points are distributed among this 5 nodes, and they will each have the distance. And then like let's say Here we have three data points, and we will assign cluster 1, cluster 2, and then we will compute the distance for each cluster, and all the ranks will do for their own data, and then it will they will give the distance to the main node, and they will compute the mean, right? And then compute after computing the mean, again it will send the broadcasted updated centroid to their these ranks nodes, and then it will do it until centroids are no longer moved or changed that much. So that calls convergence. So here master node initialize the centroids, broadcast to the worker node. So it will broadcast the centroid that have been initialized to each worker, and each worker will assign the points to the closest centroid. It will have their own particular data. If there are 5 workers and there are 1,000 data point, all the worker will get 200 data points, and then they will assign the distance. Based on this distance, they will assign each data points to k nearest um, centroid, and they will basically compute the distance, and then they will compute the partial sum, because we need to have a mean, right? So they will um, compute the sum, and then the master will aggregate the data. They will find mean based on those partial sum, and then they will like again update the centroid, and again this process repeats that it will broadcast to the worker, and then again will process increase, and they will check the convergence, like if it is done, no more centroid updatation is there, then it is done, and we have found the perfect K clusters. So, and with the data points, and yeah, so that is about it. And like we have these kind of frameworks that are useful to do this threading or ranking mechanism. So, yeah, and yeah, this is ChatGPT generated. So, be careful. You can read your own research paper links. I'll provide it in description. Thank you.